All right, everybody. Today I'm going to be going over some percent yield problems, the ones on the back, some of the harder ones. So basically what I'm starting with here is that I'm saying is, hey, I have 140 grams of C2H4, okay? And I need to know how many grams, theoretically, I would get of C2H4Cl2, okay, of this one right here. Now, this right here, reading the sentence, this right here says that I got 500 grams experimentally. Okay, so I want to know how many theoretically I should have gotten. So I start with what I started with right here, and then I kind of put in right here what I want, right? You know the deal. And I'm going to do a little side hustle right here and figure out, get this from grams of C2H4 into moles of C2H4. So this right here is my side hustle. This one's kind of nice because it's 1-to-1 ratio. So I'm going to go 1-to-1 ratio. And then I have to do another side hustle to figure out my other molar mass. And when I do, I find it's this one right here. So now I multiply everything on top, divided by everything on the bottom, and I get 493.75. So what does that mean? So that means theoretically, I should have gotten 493.75 grams, but in the experiment, I actually got 500 grams, which is strange. You usually don't end up with more. So what I do is I take this number right here, 493.75, 493.75, and I divide it by 500, and I multiply it by 100 to turn it into a percentage, and I get, oops, I'm sorry, I did that incorrectly. Theoretically, I should have gotten 493, so it's actually 500 on top divided by 493.75, and I got 101. I got 101.3%. Okay, cool. Let's go ahead and do this next one. So this next one is I'm starting with 89 grams of sulfuric acid, and in the experiment, I produced 7.1 grams of water. Okay, so I need to find out how many grams of water theoretically I produced. Okay, so start with what I start with, which is 89, and I want to figure out how many grams of water hypothetically I'm going to get, right? So first thing is my little side hustle right here to get this into moles of H2SO4. Then this is another one where the balanced equation is pretty nice. So it's just a 1-to-1 ratio, which is kind of cool. And then I have to go from moles of water into grams of water, and I go like this. And then I multiply 89 times 1 times 1 times 18.02, divide it by 98.08, and I get 16.4 grams. So theoretically, I should get this. Theoretically, I should get this. The theoretical yield is always what you get in the stoichiometry, and the experimental yield is what you got in the experiment, or in this case, in the problem. So now I take 7.1 and I divided it by 16.4, and I multiply it by 100, and I get 43.3%. All right, cool. Last one, you got to do a little balancing of your own here. I got a 2 here, a 15 here, my goodness, a 12 here, and a 6 here. So what is percent yield is when I start with 7.8 grams of benzene and I form 21 grams of carbon dioxide. And an unspecified amount of water vapor. So this one sounds a little confusing. So we only know that there's 21 grams of carbon dioxide, and that's what we're going to compare it to. So we need to figure out how many grams, hypothetically, theoretically, of carbon dioxide. So I start with 78 grams of C6H6. I want to figure out how many grams of carbon dioxide I have. First thing is I'm doing a little side hustle, figure out my molar mass of C6H6, put it right here. Now on this one, my balanced equation, I have to go from moles of C6H6, which is a 2 on the bottom, to moles of carbon dioxide, which is a 12 on top. Okay, and that's based on the balanced equation. And then right here, I'm going to go with 44.01 grams. That's my side hustle to figure out the molar mass of carbon dioxide. So multiply, 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 divide, divide, and I get 26.4 grams of carbon dioxide. And that means that, but in reality, I got 21. That's what the problem gives me. And I calculated 26.4. So that means I get a percent yield of 79.5%. That's this number divided by this number times 100%. All right, thanks for watching.